Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills they need to get their first software development job building Windows and web apps at the world's best companies as quickly as possible. In this lesson, I want to talk about layout, in other words, how controls are positioned and arranged on your app's user interface. And so my game plan goes like this. We're going to start by talking about the two primary elements that are used in layout for phone apps, specifically the grid element and the StackPanel element. With regards to the grid element, I want to talk about how to define rows and columns and talk about the various sizing options and techniques that you can use to get the most from the grid control, the grid element. And then with regards to the StackPanel element, we're going to discuss how to change the orientation of items that are stacked next to each other from horizontal to vertical, and also talk about the alignment of items as well. And then finally, what I want to do is kind of switch directions a little bit and talk about how event handlers are wired up from both XAML and C#. We've covered this in the C# Fundamental series, but I want to recap that and talk about it one more time just to make sure that it's solid in your mind before we continue on. All right, so let's begin by talking about the basics of grids. The grid element is used for laying out other controls. It allows you to define rows and columns, and then each control that you embed inside the grid can request which row and column that it wants to be placed inside of. So whenever you use the blank app template, as you see I have here, and I haven't made any changes to it just yet, you're provided very little in terms of guidance to get started with. You just have an empty grid. No attributes set on the grid, nothing. So let me start by pasting in a name for this grid. You only have to give XAML elements a name if you are planning on referencing them from other XAML elements, or if you're planning on referencing them in your C# code. And I'm using the name layout root. It's a common convention that's used in the other templates that we'll see upcoming in this series. Now, it appears that there's no rows or columns defined in this grid. However, by default, there's always one row and one column, even if it's not explicitly defined. And these make up the full vertical and horizontal space available, and it represents one giant cell in the grid. All right, so any items that are placed between the opening and closing grid, like we saw in our previous examples, they're understood to be defined inside of row 0, column 0, that implicit row and grid definition that you don't even see defined here. All right. So let's talk about how to define rows and columns. Let's take a look. Let me actually just close this down. We don't need to save anything. And let's open up this project. You can find this project wherever you're currently viewing this video. There should be a download link somewhere on the page, probably underneath the streaming version of the video, maybe beneath the little paragraph description of the video itself, maybe some links in there. Okay, make sure you download all the source code available for this series. Inside of the what is this, lesson number 4 folder, there will be a number of projects. Open up the project that is called row definitions. And you can see here that I have a simple grid with 2 rows defined here in a grid.row definitions, that property element syntax that we talked about in the previous lesson. And so as you can see, we defined a row definition with a height of auto and a row definition with a height of star. Now there's a third option as well where we can define the actual number of pixels. In fact, if you take auto and change that to like 200, for example, you can see that it will create the height of the row to 200. Now, let's remove that and move it back to auto, but take note that there's some black lines above and below that, that beige bar at the top. I'm just going to return this back to auto. That beige bar at the top is actually a rectangle element, a rectangle object, and we set its height to 100. Therefore, when I set the row definition's height to 200, it left plenty of empty space and it centered that beige rectangle in the middle of that empty space. All right, so that should give you some clues as to how things are laid out by default inside of a grid. They're going to be centered within their height or width or whatever the case might be. Notice that we're not giving a width that implicitly states that use up the entire space that's available. I could change this and set the width to 100, and you can see now that the width of the rectangle is basically it's a 100 by 100 rectangle, giving plenty of room on the left and right hand side. Notice that it has been by default aligned in the center of that row definition. All right, but let's go ahead and remove that and get back to its original state here. All right, notice that I have assigned this rectangle to row equals 0. I didn't even define grid.column equals 0 because, again, that is implicit. In fact, I could leave this definition off here and this would still work correctly. I'll just remove it and nothing will really change because I didn't have to explicitly state which row that I was going to put this rectangle in if it's in the very first row in grid.row equals 0. All right. So a lot of ideas there floating around, just the defaults and the nature of why XAML is great is because you don't have to define each and every little thing. It will just give you the defaults and get you close to where you need to go without having to make a lot of changes. But notice that what is defining the height of this row? We set it to a specific pixel count of 200 a moment ago. I could set it to a specific pixel count of 100. However, the word auto here, it means that take all the items that will be inside of this row, calculate the height of those items, and then use that as the height of this row. And so that's how it works. It sees that there's only one item in that row. The height of that one item is 100. Therefore, make the height of that row 100 because we set it to auto. The second item, you can see here that the height is set to star. And we'll talk more about star sizing in a moment, but that says use the remainder area that's available. So if this is only going to be 100 high, then the second row will be all the rest of the space available because of the asterisk, the star sizing. And we're just setting the second rectangle into the second row, grid.row equals 1, and then giving it a fill color as well. All right. Let's talk more about star sizing because you have some other options there. So I'm opening up a new project called star sizing. You can see here I've defined 3 rows and 3 rectangles, a red rectangle, blue rectangle, green rectangle set to row 0, 1, and 2 respectively. Also, take a look at the row definitions. I have a 1 next to the star here, a 2 next to the star in the second row, and a 3 next to the star in the third row. Well, this basically is saying give me a share or give me 1 share of the height that's available, give me 2 shares of the remaining height available, give me 3 shares of the remaining height available. So the layout engine will take all of that into consideration and determine that there will be 3 rows and that there will be essentially 6 shares to be divvied up, 6 shares of height to be divvied up between those 3 rows, and then give them 1 share, 2 shares, 3 shares appropriately. And then we're merely just putting our rectangles in each of those rows, and they'll fill up the height. Since we didn't define a height or a width, they'll fill up that entire space inside each of those rows. All right. Let's open up one more example here and take a look at this project called Grid Rows and Columns. And here what I've done is created 3 rows and 3 columns, each with star sizing. So just take up an equal amount of width and height. Okay, and so we have, as a result of 3 rows times 3 columns, we have 9 cells, and I've just placed the number 1, 2, 3, 4, 5, 6, 7, 8, 9 in each of those cells. Now, you'll also notice that I did this with a text block. This first text block does not set the grid column or the grid row, and that would infer what? To be implicitly placed in the first row and the first column. Additionally, take a look at number 2. I'm only setting grid.column equals 1. What does that mean? Well, it means that's implied that grid.row equals 0 and the column would equal 1. And so you see that continue on here. Like, for example, number 6, we're setting both the row and the column the second row, the third column, 1 and 2 respectively. Okay. All right, let's move on to another example. This one is called alignment and margins. And you can see here that I've created a series of rectangles. Notice that I haven't created any rows or columns, that there's just the implicit row and column to create one large cell in the middle. And so most of this example should be obvious if you stare at it for just a few moments. But there's several finer distinctions that I want to make about alignments and margins. First, this example points out how vertical alignment and horizontal alignment work even in a given grid cell. And the same will hold true when we talk about stack panels as well. The alignment, whether it's horizontal alignment or vertical alignment attribute, will pull controls towards their boundaries. By contrast, the margin attributes, like you see defined in some of these latter examples here, they will push controls away from their boundaries. So that second observation is the odd way in which margins are defined as a series of numeric values, like you can see here, separated by commas. It's a convention that's borrowed from cascading style sheets. The numbers represent the margin pixel values in a clockwise fashion starting from the left side. So in this case, take a look at this yellow rectangle. Margin, so we're setting the alignment to the left, so that will pull the rectangle to the left, and the alignment, vertical alignment is set to the top, so it will pull the alignment of the yellow rectangle to the top. Then margins start to push things away. So we'll say push the margin 100 pixels from the left out. So we pulled it to the left and now we're pushing it back out 100 pixels, and then the second value will be to the top. We have pulled the vertical alignment of that yellow rectangle to the top. Now we're pushing it down 100 pixels. And so the same thing is true with this second example here. Remember, we're starting on the left side and working our way around with these values. We are pulling to the left and bottom, so left and bottom, but then the margins will push the white rectangle 50 pixels out towards the center, and then it won't push the top or the right, but it will push from the bottom margin, from the bottom of the viewable area up 50 pixels based on this last number 50 down here. Okay. Okay, so if you take a look at one of the previous examples here, let's take this one for example. Notice how I'm using star sizing, or if we go back to take a look at this example, we're using auto and star sizing. It's generally preferred that you use auto or star sizing to lay out the controls in your app. Resist the urge to set heights of rows or widths of columns in absolute pixel values, because you don't know the screen size of the device that your application will be running on. Some phone screens have wider or taller dimensions than other phones, and therefore if you use a more relative type of sizing, you'll get better results and your apps will more likely lay out more nicely given every screen size that's available on the Windows Phone. Having said that, when you're working with margins, however, you'll be working with absolute pixel sizes like we've done here. All right, why is that? Well, margins are expressed in exact pixels because they're usually just small values to provide spacing or padding between two relative values, and can therefore be a fixed value without negatively impacting the overall layout of the entire page. Okay, so we've talked about grids, how to create rows and columns, how to set their widths and heights, how to use relative spacing for the widths and the heights of rows and columns, and then how to use absolute pixels for margins. What we want to do now is change our discussion over to the stack panel, which is the second way to lay out a given, to lay out the controls on a page. All right, so what you see on screen is a slightly more advanced version of the stack panel. We'll come back to it in just a moment here. At a high level, a stack panel is pretty simple. It's just going to allow you to arrange controls that will sit next to each other in a vertical fashion or a horizontal fashion. So it's just think stack panel, think of things stacked up in a flow-like structure, either from top to bottom or from left to right. All right. And so when you keep that in mind, all we're really doing here is using, in this more intricate example, a series of stack panels. So we've defined one stack panel that has one rectangle, and then next to it another stack panel, all right, which defines additional stack panels and rectangles. But here, this topmost stack panel is set to horizontal, so we're going to stack from left to right. And so this first rectangle will be on the left-hand side. It'll have a width and a height of 200, and it'll have this bisque color. Next to that is the second stack panel, which we've set the orientation to vertical, meaning inside of this area here, we'll start from top to bottom. Notice that this stack panel's orientation is set to vertical, but then it's followed immediately by a stack panel with an orientation of horizontal, which says we're basically going to create two stack panels that will be stacked on top of each other. So we're talking about a row here of these three at the top, and then a stack panel, a row with these three stack panels, or rectangles rather, at the bottom. All right, so this first row of stack panel is going to be set to horizontal. Therefore, the first rectangle will be set as this azure color right here. Next to that rectangle, there's another stack panel that has its orientation set to vertical, so top bottom, with this rosy brown on top and this dark cyan color on the bottom. And then the same is repeated on that second entire row here. We are going to work horizontally, so from left to right. The first one will have this tomato color right here, and then next to it will be a stack panel that will stack the next two rectangles vertically, burley wood and saddle brown. All right, so two different brown colors, and hopefully you get the idea there. So I would recommend that you take a few moments and attempt to match up the stack panels and the rectangles to see how this example is produced. If you think in terms of rows, and there's a rectangle and a stack panel next to it, and that stack panel may contain other rectangles or stack panels, and just try to parse through it, change the colors, and see if the rectangle you thought the color you would change, like you can change this one to red, right? Is that the one you thought? Yeah, it is. Okay. That will help you understand better how a more intricate stack panel layout would work. So as we continue through the series, I'm going to use multiple stack panels, maybe nothing quite this complex, but I'll use them to organize the various XAML controls on screen. In fact, I've grown to the point where I prefer to use the stack panel because I feel like more flexible than the grid is. However, I started off thinking very rigidly in terms of layout with the grid, and so that might be a natural place for you to gravitate towards. And so I guess this is just a personal preference. All right, so let's move on and talk about the last topic here, and that is events. If you watch the C# Fundamentals series on Channel 9 or on Microsoft Virtual Academy, in one of the last videos I talk about events. In the Windows Phone API, pages and controls raise events for key moments in their life cycle or for interactions with the end user. Now in this series, we've already wired up a click event of our Click Me button with a method that I called an event handler method. So when I use the term event handler, I'm really just referring to a method that is associated with an event. I use the term wired up to mean that the event is tied to a particular event handler method. So some events can be triggered by a user, like the click event of a button or the tap event. All right. Other events happen during the lifetime of the app, like the loaded event that occurs after a given page or control object has been instantiated by the runtime. And there are two ways to wire up an event for a page or for a control to an event handler method. Now, the first is to set the given event using the attribute syntax of XAML. So let's go ahead and just create a new project, new blank app template. We don't even have to give it a name. I'll throw this away. But what I'll do, just to kind of explain what I'm talking about here, is I'm going to add a button quickly to the design surface. And when I want to add an event, let's move this over. All I need to do is, for example, type the name of the event, for example, click equals, and then we get a little helper menu below that, allowing us to define a new event handler. Now, the way XAML works is that your elements don't have to have names. You only need a name for a XAML element if you're going to reference it from the code behind. So before I actually create this name, well, let's go ahead and do it both ways. Click equals, and then I'll just say, go ahead and create me a new event handler. I don't care what the name of it is. Bam, it'll just give me button underscore click. If I want the name of the button to be a little bit more specific, and so x name equals my button, something like that. Now whenever I go to the click equals, I can still choose that previous method stub called button click that was created last time, or I can create a new event handler, and this time it'll have the name of the element underscore the name of the event, which is the format I prefer. And so then when I right click on that name, I can go to definition, and now I can start typing inside of that event handler method. Okay. Now, as we saw in a previous lesson, another way to wire up an event to an event handler method in Visual Studio is to make sure your mouse cursor is somehow selecting either the button control in the designer or in XAML. Go over here to the events tab or button of the properties window, and then double click inside of a given event name that you want to handle. And then you can see it once again created the my button underscore click event. The final way, and we'll just go ahead and remove this click event like so. All right. The final way that we can wire up an event is through imperative code. So what I can do is my button, which is the name of our button, dot click, and I can do plus equal and then tab to generate both the name of the I guess the delegate, the name of the event handler that we want to bind the click event to. So if I were to have two buttons, let's add a second button here. Let's see if I can just drag and drop that onto the design surface, and name equals my other button. Okay, and we'll just leave it at that. Maybe we should give it some content. Other button, and we'll set its, just drag it into place here, let it generate out the margin and so forth. Now if I wanted to, I could, my other button dot click, I can set that equal to the event handler that I've already created. So I can have two events, one from my first button and my other button, both pointed to the same event handler in code. Or I could change it to create its own new one. Let me see, I may have to type some more here to get it to plus equals, tab. You can see it has created a method stub and a not implemented exception that we can comment out and remove from our app. Okay? And so that plus equal operator like we're using here It can be used in other contexts to mean add and set. So like x plus equals 1 is the same as x equals x plus 1. And that really is true here as well. We want to add and set the click event to one or more event handler methods. Here we're saying when the click event is triggered, add this method as just one of potentially several methods that are executed whenever that event is fired. Okay, we could add additional ones as well. For example, I could go my button dot click plus equals my other button underscore click. All right, and that would work as well. Finally, we have a situation where there are two buttons that can trigger the exact same event handler method, this my other button underscore click event. So in the body of this method, how can we find out which of the two buttons or other buttons or controls actually triggered this event? Well, fortunately, the Windows Phone runtime will pass along the sender as an input parameter. So since we could associate this event with any control, the sender is of type object, the type that virtually all data types in the phone and in the .NET framework will ultimately derive from. And so one of the first things that we'll need to do is a few checks to determine the actual type of the item that was sent in. So are you a button control? Are you a rectangle control? And then we can cast this sender to that specific data type and then work with its properties. So once we cast that object, for example, to a button, then we can access the button's properties and so on to determine the exact button that was clicked to fire off our event handler. In addition to the sender, we have this routed event args E, which is used for those events that pass along extra information. And you'll see how these are used in some advanced scenarios. I don't believe we'll use them much in this series, maybe near to the end. Okay? So to recap, the big takeaway in this lesson was the ways in which we can influence the layout of pages and controls. We looked at the grid and the stack panel. With regards to the grid layout, we learned about the different ways to define the heights and the widths of the rows and columns using auto sizing, star sizing, and even specific pixel counts. We also talked about how vertical alignment and horizontal alignment will pull controls towards boundaries while margins will push controls away from boundaries. And then we talked about the different ways to wire up events to event handlers and the anatomy of an event handler method's input parameters, the sender and then the routed event args. All right, so that's all we wanted to talk about here. In the next lesson, we'll actually take a look at some of the most common XAML controls that are available to us in our apps. We'll see you there. Thank you.